Okay, so we're going to look right now at the solution for the group activity. I know some of you are still wrapping it up. I got to wait for this thing so I could hit pause so it doesn't interrupt me. Otherwise, I'm listening to myself while I'm talking. There we go. Now let's get to this. All right. So here, remember, X is just the amount it was stretched. So in your case, I think the amount it was stretched was this quantity A minus X on. So far, so good, right? Is that good, Denna? Are you still there? Oh, he maybe took off.
Yes, I'm there.
Oh, there you go. Oh, yeah, I got you.
Yes.
Okay, sorry. And now when it's stretched, right, the total spring length is just, well, if we look at this, hold on, let me get this right. This distance we're told was X. And this distance up here, I think, was A. So we know it's the square root of X squared plus A squared. That's the length. And then now some of you might have had this as X un plus C or whatever. But the idea is that's the total. And so the new amount it's stretched is this. I think you're good with that, right?
Yes.
And so then you're probably good with this, and these different ways of writing this crap, right?
More or less, yeah.
You probably had this one, right?
Um, no, I had the second line. Was it the same as the first one? Yeah. Yeah, the second line.
Yeah,
I
well,
left it
and do you agree that this is D, so that's the same thing?
yeah.
All right, so that's
Oh yeah, I
good.
have to show my work. Yeah. Yeah.
Okay. All right, so that's just getting the spring energy for an arbitrary X. Oh, whoops. I hit the wrong button. All right, so let's scroll down. Now, I played around with it a bit to see, and then I was like, this sucks. This new form does not increase my intuition. So I tried rearranging it, regrouping it. Nothing made it look pretty. It's just ugly. Determine the horizontal force. That's how I did it. Now, notice I had to, instead of X un or whatever, I used the terms A and B over here. And then, so yeah, I just shoved it in there. I remembered the minus sign. There's a minus sign right there somewhere. I don't know if you could see that. Okay.
Yeah.
So it didn't like X un, so I just said X un was B, I think. When I did that, I get this result. And so I just wrote that right over here. So far, so good.
Yeah, I have it still in the simplified, I think.
Yeah,
Without
okay.
yeah.
There's a bunch of different ways to write it, but yeah, okay, cool. Now, this is something that students that are learning should be careful of. It's dangerous to trust a computer without thinking, right? Because you may have told it something wrong by accident. So I checked the units. I checked that the force was 0 when X was 0. There's no force at equilibrium. There was energy, but not force. And then F sub X is negative when X is positive. We expect it to pull to the, we expect a pull to the right, or, oh, if you pull to the right, you expect a force to the left. There we go. So some people try to do cosine and crap, right? You could say, well, cosine is X over D, and that's a fine method. So you could have done the force from a spring as kx, you know, the amount it was stretched, and then you say, well, I get a cosine of that, times it by 2, and cosine is X over D. You would actually get the same junk. All right. Now, here's what you do for the part 4. Assume the card is displaced distance L and released from rest. Well, I use this equation, and that's what I was trying to guide you to. Now, in this case, I plugged in 0 because it was released from rest. There's no work. Normal force is, all that stuff, right? U initial is, oh, whoops. I think I had this backwards right here. I wrote this wrong. technically I should say plug in that for U initial, and this should be U final, I think, right? Because you're starting from over here. This is the initial state where X equals L, and you start from rest. And then your final state is when you're right here and X equals 0. And at this point, the card is moving with some speed V. So I solved that for V. And again, I think I screwed this up. This should be using X equals L. And this should be using X equals 0. And again, this number is from part 1, I think. Is that help you with that, Denna?
Yeah, that makes a little more sense.
Okay, so let's keep going. Now, if you want to plot these things, I just use these numbers. I just pick some random numbers. These plots will all look a little bit different. So rather, right, I just had it plot it. And I'm going to do this just so I could see it. I plotted the force and I plotted the potential energy. And notice the following. If I say here I have a large negative slope, I have a large positive force. 0 slope, 0 force, large positive slope, large negative force. You pull it to the right, the force is to the left. You pull it to the left, the force is to the right. It looks good. And that's kind of what I was hoping you would do.